I was thinking now about what I told you about this deployment, releasing, and the question is how is this related to ensuring quality in software projects? Because this is the title of this, the entire course. By configuring deployment strictly and automatically, fully automatically, we basically make it, this deployment script, this deployment process becomes the only door to production. This becomes the only possibility for the entire software team to put the project to put the code into production. As soon as we do it this way, as soon as we have it as the only door, then we will be able to close this door to mistakes. So, because I've seen situations a number of times in my life when there's a team of people, a group of people developing software, and every second person has access to production. And every second person can just put some piece of code to production, deploy the new product, go to production server, make the changes there, check the logs, and all that stuff. What kind of opportunity it gives to everybody? Anybody can make a mistake. They can put any code they want to production. Of course, it shouldn't be acceptable. It shouldn't be this way. We should put everybody has to knock the same door in order to put any code to production. And then on this door, we put many checks, many linters, static analyzers, unit tests, integration tests, everything. So ideally, when the deployment script starts, it has to first run all the possible checks, all the possible integration unit tests and everything. And it should take a while. It should take maybe 10 minutes, 1 hour, 3 hours, doesn't matter. And everybody has to wait. So this has to be only one door which the code must go through in order to get to production. And this is the first step, again, the first question I ask when I join some team, and the team which is working already, which has history, which has some legacy code already on production. And the first question I ask, how do you put it to production? So if there is a complex process which so many people know and many people participate in, then obviously the answer, I will not be able in this team to enforce any quality rules. I will not be able to establish any rules because many people can go around these rules. Okay, I will set the rules in the script and say no more code which break the unit test. Good, but 5 people in the team, they have direct access to production. And when something happens, and something will happen, something urgent, then one of these guys will just put the code to production, telling me and everybody, this was urgent. There's no way for me to wait for your unit test. I have to put the code to production. And this kind of excuse is very typical. This kind of excuse is very popular. They will do this. And if you are responsible for the quality, if you are the architect in the team, you're responsible for making the quality, high and maintaining the quality, then you have to understand that every second person, every person in the team is a potential enemy of the quality. Not because they are bad people, but because they don't like to wait for the unit tests. Nobody likes. Everybody likes to write the line of code and put it immediately to production and go home. And who cares what happens afterward? In order to stop that, first of all, the first thing you do is you prohibit anybody to touch the production, to touch this deployment script. So they shouldn't even have the possibility to edit the script, because if they have access to scripts, they can modify the scripts. They can remove the unit testing from there and still call the scripts and say, yeah, sure, this is the scripts I call it. So ideally, the script should be an untouchable part of the project. Everybody else just wait for the script to run, but never touch the script, never modify it. So now let me show you about the database, as I promised, but again, let me give some intro before. So the code is more or less easy. This is the previous version, this is the new version. I make the changes in the new version, I package it, I put to production, it starts, the previous container shuts down, the new container starts up, and everything is cool. What to do with the database? Let's say this container, this application is connected to the database. In database, for example, it's a relational database, so it's like some Postgres or MySQL. So there are the data in the database are organized in tables, and there are connections between tables, like foreign keys. And the structure of the tables is important for the application. So let's say we have the database with one table, and in this table we have 2 columns. Now we develop the next version of the application, and this next version of the application, we have a table, we need to change this table, we modify it. We make 3 tables, we need 3 columns now. You know, the application moves forward, the functionality is new, so I need 3 columns. So usually what people do, they do it manually, they just deploy the application to production, then they realize that they forgot to create the extra column because the application just shuts down. So they go manually to the database, they create an extra column, they again deploy the application and see, oh, now it works. This is wrong. So as you don't touch the production platform ever, you only let the script touch the production platform, then you don't touch the database manually. So you never connect to the database using any database managing tools, never. This shouldn't be allowed at all to production database. You may do this on development on a laptop, but you don't connect to production database. This should be completely prohibited. The only thing, the only person, the only machine who can connect the database is a script. The script which will change the structure of the database. So database is also is an asset just like the code. So the code lives its own life, incrementally changing, incrementally growing, and the database lives its own life, also growing incrementally. Database schema and the data together. So how to automate that? There are tools. One of the most popular tools for that is called, probably you know, Liquibase. So let's say you have, I will give you a real application which I made a few years ago, but still pretty valuable. So in this application, I'm not sure, yeah, it's pretty large. In this application, we have, so this application is a Ruby web app which relies on a Postgres database. So the Postgres database is on one server, the Ruby web app on another server inside Doku. So I deploy to Doku and I want some changes to happen automatically in the database after I deploy to Doku, and preferably maybe even before I deploy to Doku. So I use Liquibase. Liquibase is a software written in Java, open source, which inside your SQL database, inside Postgres or inside many other databases which it supports, it creates a special table. The table is called liquid changes or something. And in this table, it remembers what happened to the database, how the database was changing. And in order to make those changes, there is a list of files which I maintain in the source code, which are numbered 0, 1, 2, 3, 4, 5, 6, etc., etc. One after another, each file contains information like this. So each file, okay, it's XML, so it's better I show it to you like this. For example, this is the first file. It says, first create the table with an index. Second, create another table with an index. Create another table with an index, create. So this is how the application started, with this 1, 2, 3, 4, 5, like 7 tables. Then the file number 2. I didn't like something in this initial schema, so I was developing this product locally. I applied these changes, the first file, to my local Postgres. I did some development, then I deployed this stuff to production. So this table, this database was generated on production through Liquibase. So I didn't touch the production myself. I only told Liquibase, Liquibase, please go to my production server. These are the credentials. And deploy this first file, 0.1 initial schema. The Liquibase did that. Liquibase put all the changes one after another. This is change set ID 0.1. So it put not many, but like eight instructions there, 8 SQL instructions. And everything was good. Then I continued the development and I decided, okay, something is missing. I want something else. What was that? I said alter table, add column. You see exactly that happened. So I added one extra column locally. And then I And then locally, everything started to work correctly. Then I told Liquibase, again, go to production server. I don't want to go there. I don't want to go to production and add this column over there. So you, please go to production server, inject this, run this SQL command over there, and that's it. And Liquibase did that. If I ask Liquibase, for example, right now to go to production server and run these changes again, then Liquibase will say, these changes were already applied, so no need to apply them again. These changes were already applied, no need to apply them again. So these are like incremental changes which Liquibase remembers on the server and doesn't apply again if they are already there. That's the idea. And then I created another file. Again, something was missing. So the largest file is this one, of course, 01. Then there are small files, small increments. They're smaller than the big one, than the main one. So the next one, okay, you see alter table, I dropped some column. Then I dropped another column. Then I create some index. And then I added some other column. So these are my changes. So together with the code grows, and the modifications to the schema of the database, they also grow together with the code. When I deploy this stuff to production, this is my deployment script. So when I deploy this stuff to production, then, look, there is a command. So before I go to, this one, git push doku, you see? So this is where I push to doku. So I push to doku, it starts, and even before, and right after that, I do this, bundle exec Liquibase. So after the deployment happens, after doku says, okay, I'm okay, the server is up and running, the new server, the new container, then right after that, I say, and now deploy the changes which you can find in this directory Liquibase. And the Liquibase starts, finds the right configuration data, it knows the credentials, where to get them, and it goes to production and applies the changes one after another. In this case, and what's even more interesting is that all these changes, they remain in my local, in the repository, and when I start integration testing locally, or on the integration server or in GitHub Action, whatever, then a local Postgres server starts and its schema gets initialized using all these files which I have in the directory. So basically I have like maybe 15 files which were created during the 3-4 months of development of this application. So it's a full history of how the database schema was growing together with my code. And when I run integration tests, then all these files get applied to the test Postgres server, to the integration test Postgres server. That's the idea. Without such files, without Liquibase, I don't even know how it would be possible for me to synchronize what's going on in the tests, what's going on in the integration tests, and what's going on in production. Having these files, I have these two places completely synchronized. I know that what I applied locally, it's exactly the same what I applied to production. And it's completely repeatable. So I can repeat all the steps which were applied to production. I can see them, I can repeat them in the testing. You can even do the same for the data. So it's not always the modifications with the schema of the database. Sometimes you can even insert or remove some data in the database. For example, you see how big is the change like this? It's changed 04. You see, I dropped all the tables, almost all of them. So at this step 04, probably I don't remember what happened because it was like 3 or 4 years ago. But I can imagine now. So what happened? I decided to completely change the schema, completely get rid of the previous schema and move to the new one. So this was the old schema, and this one is the new one.
You see, it's also quite big. Maybe some tables remained, like for example, table project is still there. Look, yeah, project, I didn't delete it. You see, project is not here. But cause, yeah, cause was deleted. So many tables I completely redesigned. But I didn't just redesign going into some local database, making changes. Everybody forget this. I even forget this. I just made the changes, go to production, made the changes. This information is lost. But this is not lost. It's tracked. It's fully traceable. I know where it started, and I know where what changes happened, and maybe I can even explain why. There is no explanation here, but I'm sure it's possible to explain why these changes are where they happen. You can give some explanation here in the comments and something like that. So you're basically maintaining the life of a schema in a database. And again, of course, in this case, you control the quality. How you control the quality? Because you can, well, first of all, you can see what people are doing. So I was working once in a team with maybe 30 different developers, and we had a quite large database, production database. And we had these changes to the database coming from different people in the team. So somebody is working on some payment system processing, and they need some extra column in some table. So they don't just come to the database administrator and say, please add the column because I need it. But they put this column into this table, into this file, XML file, and they send it together for the code review, for the as a pull request. So in the pull request, we receive the code together with the SQL instruction to change the database. So the person who reviews the changes, the suggestion for the new feature, the person looks at the changes. This is how you change the code, and this is how you suggest to change the database. So if we accept this pull request, then the new code will go to production, and the database will change. So the pull request can be reviewed by database administrator and by the project architect and maybe other programmers. But before we introduced that approach, before we started doing it through Liquibase, that's exactly what was happening. People were just going directly to database administrator, sitting next to him and telling, please change this database because I need this and this and this table, because look at this table, we missed this column, we missed this index, we missed this foreign key, please introduce these changes. And people were doing that, and tomorrow somebody else comes in and say, why did you do it? And the database administrator maybe even don't remember what was done. And database administrator was even recording in some text file, recording the changes he did for the database in order to have some proof, in order to explain, like, hey, I didn't do it by myself, this guy asked me. And these changes, they were done because this guy asked me. So that's how immature this process looked before we introduced Liquibase. After Liquibase, absolutely gone. There's no manual review. It's only the traditional, the normal code review, the normal peer review of the changes through pull requests. So what's in the pull request, we just accept or reject, and the database changes go together with code changes. And you know, the same system exists for NoSQL databases. For example, for Mongo. For Mongo, there's a system called Mongo. I don't remember, I was using it. It's called MongoB. So this MongoB is the system which does exactly the same for MongoDB. So you explain in this MongoB, you create this file. I don't remember, it was like 5 years ago, but you create the file in JSON format, you tell this MongoB what you want to have in this MongoDB, and it does that for your MongoDB database. Because MongoDB is not SQL, so there is a completely different syntax, but still people create instruments like this, which help you maintain the quality of your database. So this is completely about quality. You can go without it, it's no problem. You can have the same, I mean, you can modify the database the way you want, but just like the code review, just like using pull requests, just like using branches in development, just like not allowing programmers to touch the master branch, and not allowing programmers to touch the production, not allowing programmers to touch the database in production, the same goes for the Liquibase. So we restrict programmers. In order to achieve quality, we take permissions from programmers. We take the authority from programmers. Programmers must be able to do as little as possible in the project. As little as possible with production, definitely. They can do anything they want in their branches and then send the changes in form of a merge request or pull request, and then we, the team, the architect, whoever is responsible for that, make a decision what to do with that. But allowing programmers to do more than they should is actually like giving the green light for bad quality. So that's what I want for you to understand. That if you want quality, you inevitably will offend some programmers. We'll tell them that no, you guys, you're not allowed to do that. And not because we don't trust you, but because we don't trust you. It's exactly why we do it. We shouldn't trust ourselves. I think that's one of the reasons for low quality, one of the main reasons. We trust ourselves too much. So we believe in us, we trust that we are smart, we trust that we are competent enough, we trust that our skills are high enough, or we trust that we know what we're doing. And that leads to problems, that leads to troubles. We should don't trust ourselves even. Don't believe that you know what you're doing. Expect yourself to make mistakes. And the more instruments you put in front of you, the more tools will be staying on your way and do not allowing you to do something, then the better will be the quality, the higher will be the quality. Unfortunately, what I can say, unfortunately, we on the market right now, we don't have enough of those instruments, I believe. I think we still have plenty of room for creating new instruments, for giving more to programmers, for making more instruments which will hit us when we do something wrong, which will prevent us from doing many things. So, for example, look at this, configuration files. There must be tools which somehow enforce us to configure our projects using some best practices. But these tools still don't exist. I mean, if they exist, they're very primitive. For example, for Maven, for Ruby, they catch a few things, but not massively. I was even thinking some time ago, let me finish with this, I was thinking some time ago and still thinking that maybe it would be good to create some sort of a project which would just like those static analyzers and linters and tools we discussed before, who look at your code and tell you that your code doesn't look as, as usually the code should look. So people, like I explained to you, people like collect knowledge from different sources and then they create a linter which enforce some style on your code. They tell you, please code this way because we believe this is the right way. And we may potentially have a tool which will tell exactly like this, like give you this information like this, but about the way you manage your repository. They will, for example, go into your repository and say, you have the database, but you don't have Liquibase. We see that you're using database, you connect to SQL database, but we don't use Liquibase. That's the problem. Or for example, you do releases, but you don't have tags. Or for example, you have tags, but you don't have releases. Or for example, you don't do releases frequently. So your recent release was 3 months ago, and before that it was 5 months ago. Something is wrong, so you better do it more frequently. So that kind of knowledge, that kind of wisdom would be great to have a tool. Instead of me telling you this, it would be just a tool you connect to the repository, and the tool will tell you, this is wrong, that is wrong. Kind of watch what you're doing and bring this, this knowledge from the community to your repository and enforce you to do the right thing, to organize your work, to discipline yourself better. Maybe that tool may use machine learning, potentially. Maybe this tool can be rule-based, I don't know. But that would be great to create such a tool which would be able to help us.